compass needle, north of compass needle will be repelled by this north pole, so it will orient in this way. It will orient in this way. Then remove the compass needle, put a point, right? Now put this compass needle once again here. Now in this position, the orientation of compass needle will change. That will change in this manner. It is because this needle is moved slightly away from the north pole, so its influence will be decreased. Its influence will be decreased. So at this point, when we take this compass needle to this point, it is influenced by both the north pole and the south pole. Here also it is influenced by both north and south pole. Since it is very closer to north pole, so only we show the influence of north pole. Here it is away from the north pole. Now we are showing that the needle is influenced by both north and south pole. Then put a point, remove this needle and place again like this. Now again the needle, orientation of needle changes. Then again it is removed, placed. Here it is changed in this way. Now put the point. In this way, if you keep on changing the position of compass needle, you get this kind of path. The orientation of needle continuously changes. Finally, now it is reaching this point. In this way, it reaches. Finally, we are reaching this end. So this is how we are drawing the line by using the compass needle. We are putting the points. Now, by removing the compass needle, if we join all the points, we will get such kind of line. Now, what it is showing? It shows that it is the path along which a compass needle moves inside the magnetic field. But instead of using the compass needle, we can say it is unit north pole. Why should we use that unit north pole? That is used for the calculation, but saying unit north pole, it is hypothetical because single pole is not possible. Here we are using the unit north pole. It is only hypothetical. So that magnetic field line, this line is known as magnetic field line or magnetic line of force. So the magnetic line of force, it can be defined as, it is an imaginary, it is only the imaginary line. No such line presents around a bar magnet. So the imaginary curved line, curved path along which a unit north pole moves inside the magnetic field is known as magnetic field line. If we plot number of lines around this magnet, we will get such kind of pattern, magnetic field pattern around this bar magnet. We get any number of lines can be drawn, and these lines are drawn like this, right? So if the curvature, if the radius increases, this may be shown in this way. It may be shown in this way. So this is the magnetic field pattern around a bar magnet. Now in that plotting of that field line, it was observed that the magnetic compass needle is appearing to move from north pole towards the south pole. That's why the direction of these lines has to be mentioned. They are leaving the north pole and enters into south pole, right? Enters into south pole. This is the magnetic field pattern around bar magnet. In this chapter, the direction of lines is very important. And while drawing this magnetic field pattern, we are drawing all the lines. Now here it appears that the lines are parallel, but in actual sense these field lines are not parallel to each other. As we draw number of lines, every line will be away from the previous line. That means the gap between two lines, it will be less. Here if we draw one more line, now the gap will be more than the previous line. So as we draw number of lines, the gap continuously increases. So this is how we draw that magnetic field lines. Now these field lines are having some properties. That is properties of magnetic field lines or magnetic lines of force. Now let us talk about the properties of magnetic field lines. Properties of magnetic field lines. Magnetic field lines or magnetic lines of force. Right? Okay. So suppose if we draw a magnetic field line, suppose this is a magnetic field line. What the field line actually represents? This field line represents that a unit north pole moves along this path. But at any instant, what is the direction of motion? Obviously, it is along the tangent. It is along the tangent. So this is the means direction of this unit north pole at that particular instant. When we draw number of lines around the bar magnet or around any magnetic source, then no line will intersect each other. No line will intersect each other. That in that case, that no magnetic field line intersect each other. Magnetic field lines never intersect each other. So why they do not intersect each other? Suppose if we assume that the two lines are intersecting. This is one field line, this is another field line. They are intersecting each other. If they intersect, at the point of intersection, what happens? So at any particular point, it represents the unit north pole tends to move along the tangent. Here also, at this point, it has two tangents. One is for this line, another one is for this line. That means the single unit north pole tends to move along this direction and also along this direction. But this is not possible. A single object can move only in one direction at any instant. So we can say that the magnetic field line, intersecting of magnetic field lines is not possible. So this is one property, basic property of magnetic field lines. Now from the figure of that magnetic field pattern of bar magnet, if we observe that the magnetic field lines are leaving the north pole and enters into south pole. They are leaving the north pole and enters into south pole. They are only entering. They do not end at the south pole. That means if we draw the magnet, bar magnet, a line is leaving the north pole and enter into south pole, right? But if we are able to draw the line, it definitely flow through this magnet. So that means magnetic field lines always forms closed loop. It always forms closed loop. It is also one of the property. They never intersect each other. They always leave north pole and enter into south pole. They always form closed loop. They do not break. They have no origin, no end point. So these are the some properties of magnet. Now the remaining things will be discussed in the next video.